Hi, my name is John, and I'm going to be picking up with another episode dealing with Bayes' theorem. Before doing so, a couple terms that I want to go over. Specificity is the probability of a positive test given a user, or meaning somebody who should be positive. So we're thinking in terms of, let's say, drug testing. Okay? So if somebody is a user, we want to find them to be positive, right? And conversely, if somebody is not a user, we want to find them not to be positive. So specificity is the probability that you will find a positive test given that you do have somebody who uses. Sensitivity is the probability of a negative test given a non-user. So again, it gets to really, how likely is it to detect a user or non-user. Okay? So let's assume we have a population of 0.5% cocaine users. Let's also assume 99% specificity and 99% sensitivity. Okay, so we have this information from past experience or past data. And, we have pretty good tests, it looks like, right? 99% of the time when we have a positive test, 99% of the time given a user, we will find them to be positive, and 99% of the time given a non-user, we will find them to be negative. Okay. We're going to use Bayes' theorem and see how this plays out here. So let's say that A represents that a person is a user, and B represents that they test positive. Remember, or recall, I should say, the probability of A given B equals the probability of A times the probability of B given A over the probability of B. This is Bayes' theorem. Recall, this symbol means given. And what do we mean by given? It means we've established what follows this vertical bar. So another word for given is assuming. So assuming we have B, right? So this is the probability of A, assuming we know B to be true, equals probability of A times the probability of B, assuming we know A to be true, over the probability of B. Okay. So what is the probability of A? Well, that's the probability of a user. We know that a user is 0.5%. We're going to write that as a decimal. It's 0.005. What is the probability of B given A? That means the probability that you test positive given that you are a user. Well, we already said that. That's the specificity, and we said that's 99%. So that's 0.99. What's the probability of B? They're the denominator. This is a little bit different. Okay? The probability of B that you test positive, that's not directly given to us, but it's, you might say, indirectly given to us. And what we need to do is we need to basically break this into parts. And how do we think of this? Well, you can test positive by either being positive or not being positive, right? In other words, testing positive branches down into two parts, you might say. You test positive, but in testing positive, you might be positive or you might not be positive. We need to cover both of those situations. Okay, so we're going to write it this way. So you test positive. Okay, but testing positive, you might be positive or not be positive. Okay. What's the probability of testing positive and being positive? The probability of testing positive and being positive, well, let's see. Being positive is 0.005. Testing positive, if you are positive, we earlier said is 0.99, right? The probability of not being positive and testing not positive, or excuse me, testing positive, I'll go over these numbers again, they're a little confusing. The probability of not being positive is 0.995. How do we know that? That's real simple. If 0.005 are users, 1 minus 0.005, which is 0.995, are non-users, while testing positive. And here we need to look at, well, if you are not positive, what's the probability that you test positive? It's actually 0.01, right? How do we know that? Because we said that if you're not positive, 99% of the time, you will show up negative. Well, that means 1% of the time you show up positive, okay? So again, these four parts are user, found to be a user. This is non-user and found to be a user. Now you might say, well, wait, why did we say, so we matched up user with found to be a user, but here non-user, why did we again say found to be a user? Because again, it comes from this. We're testing positive, right? We're saying, okay, what ways can you test positive? You can test positive by either being positive or not being positive. Here's the case where you are found to be positive and you are a positive. Here's the case where you are found to be positive, but you are not a positive. So those are the two branches that this comes down to. Okay. Symbolically, we can actually write this probability of B. Sometimes, excuse me, let me back up a second. Sometimes it's easier just to kind of do it in numbers, but if we wanted to do this symbolically, we could. This probability of B breaks into the probability of a user, which is the probability of A, times the probability of being positive given that you are a user, which is the probability of B given A, plus, this is the probability of a non-user, we would say the probability of not A times the probability, I'm sorry, let me back up here a second. Oh, let me scratch this. Okay, backing up. This goes into parts. Again, we can either be a user, which is the probability of A, and we can be found to be a user, which is testing positive. That's the probability of B given A. I left this given out before. Plus, this second part is the probability of a non-user. We can actually write the probability of not A times the probability, again, of testing positive given not A. Okay? So again, it's a little kind of cumbersome, you might say, but we break it into parts, and this actually just comes from a basic concept in probability, which is that if you have two mutually exclusive situations, which you do, you can add the corresponding probabilities. Okay. So we're going to put this all together. Well, not really put it together. We're going to add it, right? So adding the denominator, we get 0.0149. So we now have 0.9, we have 0.005 times 0.99 divided by 0.0149, and that is approximately 33%. Okay, so what did we end up finding? Kind of a surprising result, okay? And this is why you need to be careful with, drug testing, and numbers can be a little bit surprising. So what did this end up saying? It said that the probability of a user, given that you test positive, is a mere 33%. Wow. That means if somebody goes out and takes a drug test under these conditions and they test positive, well, most people are going to think, they must be a user. Nope. It's more likely that they're a non-user still that they're a user. It ends up being 33%. So kind of a surprising result. Again, well, I hope you liked it. If you have any questions, feel free to put them in the comments section, and I'll do my best to get back to you. Thank you for listening, and don't forget to hit the subscribe button.